much. Oh,
We're having technical issues.
We're totally not experimenting with things right now. Yeah.
Hello. All right.
Hi.
Hopefully that's working. Of course, I have a bird who keeps being a butt and being in front of my face on the screen.
Wow. You're like clouded out by the green feathers of your parrot, and it's incredible.
It's just this mysterious quadrant over there. You have sounds for clues. Yeah. It's amazing.
Yeah, it's just being like super talkative today for some reason. But yeah, so this is our first time trying to use StreamYard. It may or may not be working properly because I saw comments coming in before I hit to go live. So I was a little confused. I don't know if we were already live or what was happening, but Twitch comments were coming in and didn't click it yet. So, and we're also attempting to do it on YouTube as well. Whether that is working or not, I guess I will find out soon. So yeah, new experimentation now.
Yeah. Welcome to the stream, Cora. It's so lovely to have you here always.
Thank you. It's so nice to be here. And yeah, I think I also have to get used to where to look, and it's a little strange. I'm going to have to get a better setup where like a second monitor is actually in front of me, so I don't do this kind of thing.
I mean, it's okay. Like I think it's a cool streamer thing to like look off to the side at your other monitor.
Something
like,
right.
Just need like purple lights in the background, right? And like,
yeah. We'll get there.
So, how's your weekend been, Cora? Did you do anything interesting?
Besides prepare for this demo.
We're about to find out how your weekend was.
Yeah. A lot of it was this demo. But no, I went running a little bit. It wasn't so cold. I'm in New York. And so, you know, it's cold, but I feel like the idea that it's cold is worse than you step outside and it's actually not that cold. So I tend to like go out running and then like I'm like, opening my jacket and taking off my gloves and like just, shedding layers so I overestimate it. But it's nice. I haven't been running in a little while. So it was nice to kind of try to start that habit again. That was
nice.
My accomplishment. Yeah.
Yeah, good job. Exercising when it's cold outside is definitely a problem to solve because it is cold if you're standing still. But
Yes. Yeah. It is the solution.
Yeah. I'm going to do in April around my birthday, I'm going to do a bike trip across Missouri from around there's a trail called Katy Trail. And it's basically a train track that's been converted into a bike path. So it's nice and flat and paved. So I feel pretty safe about it. But it's also 200 miles. So it sounds like a big accomplishment, but it's like the lowest level. But anyway, in Missouri at the beginning of April, I think it's going to be cold. But then all of my clothing I have to take with me the whole trip. So I learned from touring in a band, wear all black all the time, because then if it gets dirty, you can't see it. And also everything else. Yeah. But then I'm also taking recommendations for like, if anyone has, I know there's like fancy lightweight clothing that will keep you really warm. Right. And so I haven't had a need for that in my life until now. But if y'all know the fancy brands, I'm in the market for.
Oh, I bought an Arc'teryx running jacket. I got it from a website that gave me because it tends to be pricey, and they gave me a really good price on it. But I swear by that jacket.
Yeah,
for hiking, and I ended up running with it. What's that?
That's exactly the kind of advice I came here for. Yeah. That and kpack.
Yeah, Arc'teryx and kpack. That's so awesome, though. My dad got really into cycling when I was a teenager, and so we used to do like some short like bike trips, whether it was like with my siblings or not, but with my dad. And so I never did this, but for many years I would go to this website. I forget if it was like Bike America or Bike for America or America Bike, one of those, and they had like a 6-week cross America trip. You could buy just like, you could buy like a segment of it, or you could go on the whole like end-to-end thing. And so it was always this like fantasy of mine. But I don't know if I could do it anymore. Like when I was 30, I was like, oh yeah, one day when I have time. And now it's like, oh, I think I missed the boat on that.
I'll let you know. I'm not treating
Still
you
try.
good. Yeah. But yeah, there's always time. What's cool about it is since it used to be train tracks, there are all kinds of little towns along the way. So there's like bed and breakfast. And then since I'm vegan, and since a bunch of hippies want to do this sort of thing, there are plenty of vegan options too. So here goes nothing.
It's going to be great.
I'm just going to do it. Yeah. It's like worst case scenario. What? It's like a really long Lyft ride with a bike. I don't know. It'll be okay.
I always say like day 1 is training for day 2, and that's training for day 3. By the end, you're ready to start over.
I still need to get my bike from my parents and see if I even fit on it. It's from like 7th grade. I was too short then and might be now. And I'm sorry, my bird decided today was the day to be super vocal.
Your bird's been around long enough. It thinks it's just another host. It's
yeah,
like,
yeah.
He knows the sitch. He knows the details.
Tiffany muted the bird.
Yes.
Take that.
Yeah, I think Tiffany's bird's actually going to be taking over my tweeting in the shows.
What?
I see what you did there. Oh, and yeah, sorry for the few times. Like sometimes I'm not there, and sometimes it's bird butt. So this is what I get for being a godparent of this bird.
It's no longer a PG stream we got here. We gotta. We have a lot of love in the chat from Java Grunt is excited. Hey Doomsy VMware is hyped for kpack. Jemis says hi all. Hi Jemis, good to see you. Thanks for coming.
Oh, and for those who don't know, Java Grunt rejoined us and is part of our team now.
Woo woo.
Yeah.
And we have a new team member, Dan Vega. Hello, just tuned in. We're really excited to meet you. We see him around in Slack, but I haven't met you in person yet, Dan. So super psyched to see you. Thanks for coming. How about Lee? What's new with you? Get a quick Lee update and then maybe jump in.
I'm super. I have tons of stuff to share actually.
Yeah.
I spent like the last few days up at Copper Mountain Resort. It is a ski resort here in Colorado. And on Friday, there was snow. I took Friday off. It was awesome. We were up there for Tanya. Some of you know Tanya. Tanya's super cool. She's my wife. And she just had her birthday. So that's why we were getting our first laps of the season. But yeah. Any Cloud Native or vSphere admins in Colorado, if you've got an Icon Pass, hit us up. It was awesome. I bought a new board. It was
nice.
Scares me a little bit, but it was great.
And you said the first of the season. What's a season?
Yeah. So normally, like, you would only be able to ski or snowboard in the winter months, and so like if you are bound to a physical like a geo region, then you only have like the winter season for the resorts that you can get to or that you have access to, right? Because it's winter in different times of the world, but like here in Colorado, if you're just stuck, right, then the season is maybe it really gets good in like late November, and then it'll carry out until slushy snow comes in April, May, June.
Okay.
I can't imagine June being the end of snow season.
Yeah, that's
Here,
longer
like
than I expected.
But since Tanya and I weren't here in the first few months, these are our first days of the season personally, so it was pretty terrific for sure.
Nice. I like your life. I like that you were just in Hawaii, like in the ocean, and then immediately mountaintop skiing. Like,
yeah, well, and the Hawaii kind of mission was to become a proficient surfer, right? And now I get to enjoy surfing in snow in a way, right? So,
I can imagine that skill set would overlap. Yeah.
Yeah, it's like we went through kind of the waves of the holiday, you know, and then I spent a weekend on the snowpack, and now we're here on the stream for kpack, you know, so.
And with that, Cora, are you feeling ready to present?
Yeah, I was trying to get an arrangement where I could see the chat, but I don't know that I'm going to be that successful with that. So, and also see you guys. So, but I think what we have is good. So, yeah, I think I'm ready if you're ready.
Let's do it.
Cool. So I'll let you guys control, I guess, the sharing of the screen, but okay.
There you are.
Awesome. Thank you. Okay, so first of all, thanks to everybody who's here. I'm excited for this topic, and I'm excited to kind of go through this journey with you. Today there was an announcement, as you can see, January 25th, published on the VMware Tanzu Community Edition blog, that kpack right here, a Kubernetes native automated container build platform, is now part of VMware Tanzu Community Edition. So the focus of what I'm going to...
Can you zoom in on that a little bit?
Oh, sorry. Yeah, absolutely.
It's okay. Yeah, great.
Yeah.
Thank you.
Yeah, I can. There it is. Really big. So it's part of Community Edition. So kpack itself is a project that has existed for I don't know how, maybe up to 3 years potentially. But VMware Tanzu Community Edition is something that was released recently, which is a Kubernetes platform, and now that makes it easier to deploy programs on top of the platform, so that you actually build up a developer-friendly, sort of like more comprehensive platform on top of a vanilla Kubernetes. Tanzu Community Edition is here to help you do that. And so now kpack is one of the products that it packages and makes available very easily. So while we're going to be focusing mostly on kpack, I'm going to be using VMware Tanzu Community Edition, specifically what was just released today, for the demo. So that having been said, before I even get to slides, I want to go ahead and start with that installation of Tanzu Community Edition. So with Tanzu Community Edition, again, you would have to, what I'm not showing here is that I've actually installed Tanzu Community Edition, which then shows up as a CLI on your computer, so you have something to work with. So I'll be using that.
Please?
Say that again?
Will you zoom in again, please?
Oh, yeah. Yeah.
Thank you.
Okay, let me know. I think that only zooms in. Let me resize this. Is that enough, or should I do a little more? Let's see. I don't know how, like, there's things that have more output and less output, so I don't know what the formatting is going to look like, but we will.
I trust your judgment.
Deal with it. Let's see how it works. Okay, so just to show you, I don't have any. So I'm going to run a Kubernetes cluster on my local machine for this demo. You might reach for something like Minikube or Kine normally for this use case. I'm going to use Tanzu Community Edition for this. So just to show, there's nothing currently running on my Docker daemon. So I have this CLI available to me called Tanzu, which is what I got from installing. I did a brew install, but it would be in the documentation how to download Tanzu Community Edition. And then Tanzu Community Edition can start either a managed cluster. So if you want to manage a set of clusters and maybe like for other people or for different use cases, you can do that. Or you can just start up a single cluster, and it's called an unmanaged cluster. So that's what I'm going to do. So very similar to what you would be doing with Kind or Minikube, right? Just one cluster on local Docker is what I'm doing. So I'm going to go ahead and run this command and let that install the cluster while we talk about other things, and then we'll use that later. So having said that, I'm going to start my slides here. So this should work briefly as soon as. I have to give a lot of credit to Deshaun Carter, who's on the second newest addition to our team. And this whole thing about, I mean, he's been a great partner throughout in getting all this to where it is, but specifically I'm trying Reveal.js as a way of presenting slides. It's a little slower than I thought it would be. So we'll just wait for Nginx to download and start, and then I'll be able to show you my slides. Okay, here we go. So, all right, we're going to be talking about building production-ready container images at scale. So all of those characteristics. Everybody's got to be building images, so we want them to be quality images, and we need to do a lot of them. So with kpack and Tanzu Community Edition. So a lot of people today are in this situation. This might sound familiar to you, right? If you're working with microservices on Kubernetes, then you already know that a lot of us are in a situation where we have to create many images, right? That's the consequence of going from a monolithic application and splitting it up into many services, many microservices, and then deploying it into Kubernetes, that you have all of these individual components and they all have to be translated into images in order to be deployed into Kubernetes. So first of all, we're all creating a lot of images. Then if you're working on an application that has that is polyglot, or if you're supporting teams that write applications in different languages, then you also might be in a situation where you have to create different kinds of images, right? They're not all Node images, or not all Python images, but there's a few of these and a few of that. And having to do this, right, creating many applications for many images for many different types of applications has been and continues to be a burden for both developers and operators, right? You're having to, if you're a developer, you're having to do this, and if you're an operator, you're having to do this. And often, partially because of that, right? Both sides of the house are kind of working on this. Developers will sometimes do it one way, and then operators are actually maybe automating a slightly different way to do it. And so there's also a variance between maybe how you're composing a container on your local machine versus how it's actually going to be composed in a pipeline for the production deployment. And either way, we're all kind of doing it ourselves, right? Writing scripts, and you might trying to be automating it, right? You might put it into something like a Jenkins or something, maybe say, okay, we're all going to use this one Dockerfile. We're going to put it on this server. So you send me your code and we'll all do it one way. You're still responsible for creating the automation around that. So there's a lot of DIY going around. So one situation, and this was something that I recently spoke to somebody and asked them what they were doing for their company. And they said that in fact, every Git repo had a copy of a Dockerfile, and every Git repo had a copy of a GitHub action to run that Dockerfile and produce an image. So, so that's a lot of copy and pasting. And so there's probably a lot of effort that goes into creating that perfect Dockerfile, right? If you say I have Java applications and I have a Node application, so you're going to put a lot of effort into saying, okay, I'm going to write 2 great Dockerfiles and I'm going to copy paste that everywhere. And then if you're using something like a GitHub action, then you also have to take the CI automation code and copy and paste that everywhere. And then what happens when you realize that your perfect Dockerfile wasn't exactly perfect and you actually need to make this change to make it more secure or whatever it is, then you got to copy paste that into all of your Git repos, right? And that can get pretty cumbersome, and it's likely that you're going to have drift there, right? So every single Dockerfile that's there is introducing a little bit of risk, right? Which is one reason that this is what I'm positioning, that Dockerfiles in your ecosystem are bad. So look around your repos, and if you've got Dockerfiles lying around, then hopefully maybe by the end of this talk, you'll come out with a plan to improve the situation, right? So to add a little context to that, the container image is the new artifact for deployment to Kubernetes, right? It's your app plus everything that it needs and to be a runnable, self-contained piece of software, right? All the libraries, all the packages, the runtime, middleware, even the operating system. And it used to be that as developers, you would just package your application. Say, if you're working in Java, that would mean making a jar file. And that was your deployable artifact, right? That's the artifact that you handed over to the operations team. And the operations team was responsible for maintaining the virtual machines with whatever operating system they had and whatever runtime, plus any shared libraries or any packages that were necessary. And that was your deployable artifact. But then with containers, this shifted. And so now the deployable artifact is actually the container image. And inside of the image are all of those things that used to be the responsibility of the operations team. And instead, we're deploying these container images that contain all of the environment into Kubernetes, right? So there's a few challenges that you have to solve for when you're thinking about this, right? How are you going to build that image? Now that that responsibility is shifted farther left, we have to think about what constitutes a good image. How do I make sure? Because instead of having all of those bits in a single shared environment, now every single deployable artifact that we're deploying to that environment has a copy of the OS, has a copy of the middleware, right? A copy of all the libraries. And it has its own configuration, right? So how do you know that the thing that you're throwing into your production Kubernetes is secure, is quality, is well put together, right? And how do you know that for every app that's being containerized in your organization, that everyone's doing it the same way, right? If you establish that these are the right ways to do it, this is what constitutes a secure image, how do you know that everybody's doing it, right? Whose responsibility is it to do that? And what do you do after you've deployed it? How do you maintain that image moving forward? So that means that for every individual image, you have to worry about what is that base image, right? What's that OS? What are the other bits that you're putting in, packages and runtime? How do you validate that that it's correct? How can you make any optimizations? And how do those optimizations vary between, let's say, optimizations for Python versus Java versus Node? Where do you get all that know-how to make all those optimizations for every language? And how do you worry about security? Which is really interesting because the folks who have the expertise to do the optimizations for a programming language, like the Java experts, are probably not the same people who have the expertise to make sure that it's really secure, right? They're generally different groups of people. And yet we have to make sure that all of those considerations are taken care of and validated within a single image, right? So it's challenging. And so it begs the question, right? Whose responsibility is it? Is it the developer? Is it the operator? Is it the security team? Or do you kind of farm it out, right? Is it an OSS product that you can leverage, or do you look for a vendor to help you solve these problems, right? How do you do this? And as you're doing this, you want to try to avoid reinventing the wheel, right? There's things that have been proven out, the things that have been widely used, have a lot of backing behind them. You also don't want to duplicate the work, right? You want to focus your efforts where you're going to get value out of it, and duplicating work is not worthwhile. Partially also because then you have like maybe copies of a risk and vulnerability throughout your repositories or throughout your estate. And also the other question is like, who's going to support you right after this? Who supports all of the bits and pieces that you put into your container? So those are some of the challenges. And then as far as day 2, moving forward, right? Things, as soon as you have a piece of software, then it starts becoming stale, right? As soon as you release it, it starts becoming technical debt. So as soon as you have an image that has maybe a certain operating system, as soon as a vulnerability is discovered in the operating system, it's technical debt that you have to act on really quickly. Or as soon as there's just like an update in the version of Java, then that's technical debt that you might want to act on, right? So how do you decide which container images need action, and how do you roll that action through all of those? And also from sort of an operational perspective, what you want to have is a bunch of images where you know what's inside of them, right? You don't want to have a bunch of images where you're like, well, I'm not really sure what went into this image, but we're going to throw it into production anyway, right? So a little background. Dockerfile was not always bad. So I'll tell you a couple of stories just to put this into context a little better. But I remember, giving an application to an operations team, something that would work in test, right? You accompany that with like, okay, these are the libraries that have to be updated, or these are the new libraries that my app, the new dependencies for my app. So this shared library has to be installed into the environment before you deploy my application. And so for whatever reason, that would be done in test. And then when my app was moved to production, it would happen that somebody would maybe not go through the doc carefully, and there was a library that would be missing in production. And so something that worked in test suddenly didn't work in production, right? So that kind of thing, Dockerfile was a great solution for that, because suddenly the whole environment is in your control. You can say, I'm not just giving you the application plus a document of what needs to be done in production, but rather I'm going to give you this I'm going to use a Dockerfile to create an image that has everything in it. So this kind of situation cannot happen, right? What I give you is everything my app needs. So it will never be missing something in production that it had in test. Or I also remember, operations teams would have to schedule time with a bunch of different development teams to say, okay, well, can your app be down from 2 to 3 in the morning? Is that going to be detrimental to your business? Because we need to roll an operating system upgrade through the virtual machines that you're using, right? And imagine the burden on the operations team to have to do that with a number of development teams. In fact, I remember one customer that I worked with, it took them, they said it took them 3 months to roll an operating system upgrade throughout all of their Linux machines, right? Then they had to do their Windows machines. But imagine the enormous amount of work. It takes you a quarter just to upgrade the operating system. So in particular, when, I don't remember if it was Spectre or Heartbleed happened, but they weren't able to respond quickly. So they just, they patched like the machines around the perimeter, but they couldn't really get to the rest of them very quickly. So all of those situations are alleviated by having a solution like containers. And for a long time, Dockerfile was the only way to create containers, right? So it wasn't always bad, but as things have matured, the drawbacks of Dockerfile become more apparent. But on its merits, right? It's the oldest way to build containers. It's a custom script, which makes it really flexible, really powerful, works for any application, pretty easy. The syntax is very simple, so it's pretty easy to put one together. There's a lot of examples on the internet, and it's the most familiar, so it's generally like the default go-to. But just saying it's a custom script is also kind of a red flag, right? Here's an example if you're not that familiar with Dockerfile. So here's an example of a simple Dockerfile. So basically it says, I want to leverage an existing base image with an operating system, and also that also has a Java runtime environment version 8. I want that to be my starting point, and I'm going to create this directory on it, and then I'm going to copy my jar file that I built on my computer. I'm just going to copy my jar file in there and say what the startup command is. That's a valid Docker file. And then you can just throw that into Kubernetes, and Kubernetes will know to execute that entry point when it starts it up. But that's not a great Docker file. So you might have Docker files that look more like this, that are more sophisticated, that are actually have separate that might first of all include the build, right? The last one assumed you did that jar file build separately, but this one says, okay, you can just give us source code, and the Docker file will build the source code for you, and it'll do it on one image that has the JDK, and after that, it'll take the jar file, the resulting jar file, and copy that into, here we go, just copy that jar file into an image that just has a JRE. That way we're not putting the JDK in production, right? Because here's one security concern, right? Don't put stuff in production that you don't need in production, right? There's a couple of other things in here that have to do with like the order of these operations, doing the dependencies before the source code, or the grouping of operations, right? Making sure that all of these operating system things are done in a single operation, because Docker images, OCI images are composed in layers, and every instruction in a Docker file is going to create a separate layer. So you want to make sure that the things that should be together in a layer are together in a layer. But this Docker file, while it's better, it's still not perfect. It still has some, like, for example, this version of the JDK is not that specific. So if I build a container using this Docker file today, and then I build it tomorrow, or I build it on a different machine, I might end up using a different version of JDK 11 or of JRE 11, right? So even if I put a lot of effort into my Docker file, there's still some potential holes, or there's a lot of burden on me to make that decision about whether I want to pin this version or not, and what does that mean for me in the future in terms of maintenance. And even later, if I want to change that version of Java, I'm going to break this layer of the image. Therefore, all of it has to be recreated, right? That's another characteristic of Dockerfile. As soon as you break a layer because of a change, let's say you want to use Maven 3.7, that breaks this layer, and you have to recreate everything else. So just the way Dockerfile works. But right now we're saying Dockerfile wasn't always that bad, right? For a long time, it was a great solution. But those are the things that you have to watch out for, right? It's all your responsibility to know when it's good, what you're putting in there and when it's time to change it, if it's secure enough, and all of that. So, and then afterwards you have an image. Unless you have the Dockerfile that you used to generate that image, you probably don't have enough information about the image. And even then, like I said, it's not precise enough because it doesn't tell you the versions of the precise versions of what's in there. So, okay, I'm going to skip this part. We're not talking about Jib, but if anybody's interested in Jib, let me know in chat. Just another way to build images that also has pros and cons. So looking forward.
So there's a question about why clean. Oh my gosh, my bird. There's a question about why you clean up the build stage. In the Dockerfile.
Why I cleaned up the build stage? Okay, yeah. So why this? Because basically, okay. So I was saying that every single instruction here is going to create a layer in the Docker in the image, right? And so here. I want to make that layer as small as possible. So I don't want to check in stuff. It's less significant for the build image, but that's the idea, that the thought that goes into every layer that you're going to commit is partially what needs to go together because what needs to be discarded together if something changes, and then also like what's that size of that layer that if you need to transfer it over the wire, etc. So it's more of a size thing.
For the build stage, doesn't that image go away for that?
Yeah, for the build stage, for the build stage, it's probably not important. And I don't know that you'd be in a situation where you have so many of these that like you have to save space, and it would make a significant difference. So yeah, it may not be that meaningful, but as a strategy. The idea that you the things to keep in mind are like what you order, in what order do you do operations, and how you group things, and when it's relevant. I mean, people don't always do this in a two-stage Dockerfile, right? You will find this operation in a single-stage Dockerfile. So in that case, this is assuming that. As you were doing this, you knew that a build and a run stage, separating the build and run stage, were good. But that it's not actually that common, or maybe it wasn't that common a few years ago to do that. So you could find a lot of Dockerfiles where that was in the only stage. So yeah, you gotta have it all right, basically, right? There's a lot to consider, and then these are the kinds of things that you're thinking about when you're creating a Dockerfile. So if we're looking forward to a better solution, right? What are the things that we want out of an image building strategy or an image building solution? So one of them is consistency, right? You really want to make sure that everybody in your organization is doing things in the same way. That's important because once you know what the best practices are, you want everybody following them. And also from an operational point of view, you want to know that things are consistent, right, across. Speed is important, right? You don't want the build to be a bottleneck in your pipeline or in your processing. Security is key, right? That can do a lot of damage to your business if you have a breach of security. So you want containers to be secure. And then governance, right? How do you being in control, I guess. So what are the things that you need to accomplish or obtain in order to reach those goals, right? What's the prescription to getting to those goals? So one is that you want something that's easy to use, right? You want to make the famous saying is like, make the right thing the easy thing, right? So you want something that's easy to use, and it's got to be easy to use for a developer sitting at their computer. I just want to build one image right here on my laptop. I want something that's easy to use, and also something that's easy to use for an organization at scale, right? If your DevOps team is going to put a solution in for your organization, if everybody has to be leveraging it, you also want something that's easy to use. So also something that works, right? It works out of the box. We're trying to get out of the situation where we're DIYing everything and where we're modifying and customizing or scripting things. So something that actually works out of the box for the different use cases that you have, right? If you're writing applications in 3 different languages, then you want something that works out of the box for your 3 different languages, which doesn't mean that you don't have like a legitimate reason to want to customize it occasionally for your organization. So maybe something that also has hooks for customization, right? The ability to extend or plug in a very structured way so that you're not forking code and putting yourself in a situation where you can't upgrade anymore. Something that's efficiency when you're rebuilding images, efficiency when you're transferring images, especially if you're in situations where you're transferring maybe to edge nodes and things like that. So you want to minimize data transfer. When you're patching, if you have many images and you've got to change that base OS or maybe there's a CVE in one of the runtime bits, you got to have a mechanism to run that patch through the system quickly, right? Quickly and effectively. Transparency, what's in the image? How can I see? Does the image allow me to inquire and say, hey, what's inside? It's important both for an operation personnel, perhaps, but also for scanning tools, right? You want to make your app compatible with different scanning tools out there. And something that's supported, right? Where there's best practices built into what you're using, it elevates you to a better place just by virtue of using the solution. The bits are curated, that you trust the choices, you trust where they're coming from, and maybe some kind of service level agreement around patching critical vulnerabilities, right? So if there is something like a Spectre or something that the company behind that the solution is going to release an update within a short amount of time to help you protect yourself. So all of those things are important. So also, sharing is caring, right? So if you have a solution, it is important that it can be something standardized and reusable. And again, so adapting to a developer local needs, and also being something that you can use inside of a pipeline for the whole organization. Oops. And you want something that is going to give you confidence, right? At the end of the day, you're looking to have confidence that all of your apps are built the same way, that they're secure, that the configurations are good, and that your builds are not a bottleneck. And then this idea of control, right? What's knowing what's there, what needs to be patched, a mechanism to patch them well. All of those things are things we want. So what can we use? So I'm positioning this solution, not saying it's the only solution out there, but this is the best one I know, which is Cloud Native Buildpacks on Kubernetes, which is essentially kpack. Kpack is Cloud Native Buildpacks on Kubernetes. So let me do this in this order. Before I go into, I have some images, I have some pictures, but why don't I do a demo first in order to show you this? Okay, so I'm gonna talk to you about what build packs are. So how can you generate an image from your source code using a build pack? So I'll talk about that a bit, and then we're gonna get to how you use that using kpack. So how do you do that at scale? When we get to the part about kpack is a software that runs within Kubernetes. So we're going to need our Kubernetes cluster that we've kicked off at the beginning of this conversation. So if you recall, we ran for Tanzu Community Edition. We asked it to create for us a cluster right here locally on our Docker daemon. So it looks like it finished doing that. So I'm just going to check, just make sure our cluster is okay so that we know it's ready when we need it. So we're going to check, first of all, okay, so this is my kube context. So this is the new cluster, and it's already pointing me at this context. I called my cluster TCE demo. And the top one is just another random one. But the bottom two, I just want to point this out because we're not using these, but this is the other kind of cluster that Tanzu Community Edition can provision. I have this running, I think it's on Amazon, on AWS. It can be provisioned on Google and Azure, or local, or vSphere, or locally as well on Docker. But this is an example of where I created a management cluster first, and then that management cluster is used to provision other clusters where I would actually put my applications. So workload cluster. So in this case, I have a single management cluster and a single workload cluster. But I felt like for today, maybe approximating that more Minikube kind scenario was more interesting. So that's why we're going to use this one, which is the unmanaged cluster running on Docker locally. So, okay, so we know that it created it and it set our kubectl context to the cluster that we want to use. So the next question is just checking it. Let's just see. Okay, so we can get the namespaces. That's good. So you see here all the namespaces that you normally expect from a plain Kubernetes cluster. Plus you see some like basic sort of like operational framework stuff that Tanzu is using to manage to kind of make this cluster a little more rich. And then we see this Tanzu package repo global namespace, which is where it has, these are where we're going to make available certain packages that we want to be able to add to the cluster. Because one way to think about Tanzu Community Edition is, if you've heard people say Kubernetes is a platform that you use to build your platform, it's not the end goal. It's sort of like the starting place to build a platform that has more things that developers actually need, or that your organization actually needs for production. So Tanzu Community Edition is the thing that's going to help you provision and build up that platform. So the things that it does that by giving you packages that you can use. And so we have these packages right here in this namespace. So that's what those two extra namespaces are, over and above what you would normally find in a cluster. The last thing I want to check is just make sure that all of the pods are actually running, and they are. Okay, so the cluster is ready. So I think I'm going to do one more thing here before we continue, which is that this package repository, this namespace indicates that a package repository was already installed, but because kpack was added to Tanzu Community Edition literally like last night or this morning, I'm actually going to upgrade from, it has version 0.91. I'm going to upgrade the package repository to 0.92 because that's the one that has kpack in it. So that's just a little detail just to make sure we have kpack in there. And then we can actually show you. So now we have, there's two repositories. So there's this is the framework one that is more like the nitty gritty of like how Tanzu is doing what it's doing. And then this is the one that we just upgraded, which has all the stuff that we're interested in order to beef up our platform. So I'll show you this one last thing before we move on. So inside of this particular project repository, I'm going to show you what's in there. So yeah, I think okay, so here you can see that we have things like contour ingress, Grafana for visualizations of metrics, Harbor is an OCI image registry, kpack is what we're going to be talking about today, Knative helps with deploying and serving and scaling applications, Valero is for backups, disaster recovery, things like that. So this, if you think about like going to the Cloud Native Computing Foundation and picking and choosing all the pieces that you're going to need to make a platform, this is sort of like a curated set, right? Here's a suggestion of things that you can use. Plus, they're in here already as packages as part of a repository, and we're going to make installation and management of these things easier for you. So, but you're not tied to using these things. You can use whichever one. If you don't want to use Harbor, if you want to use something else, you're welcome to do that, right? These are they're available for you to use. They're not pre-installed, right? These are just packages that are like, if you want to install this, you can install this. So, okay, so our cluster is ready. Now, we are going to use that when we actually talk about kpack. But before we talk about kpack, I want to talk to you a little bit about just Buildpacks in general. So am I missing any questions, or is everything?
Yeah, there's a question. Is it possible to build images without Docker files and without an installed Docker daemon?
So the pack CLI requires the Docker daemon. kpack installed in Kubernetes does not require a Docker daemon. Is the question only for a local? Let me know if the question's only for like on your local machine. But you could do it. Like, I mean, right now, right? I have a cluster that I just provisioned running on my Docker daemon. I mean, I'm using it for the Docker daemon, right? So, but if you had kpack installed somewhere, you could just have that reading your images and publishing them to a repository. So kpack would be the way to do it, I guess. I don't know. Those are the two that I know about that use Buildpacks, right? I mean, that would be the question. Like I have that section on Jib, but there's so many reasons not to use Jib that kpack is the way to do it with Buildpacks. Okay, so 101 on Buildpacks. Why Buildpacks? So, okay, I have a demo application. We're going to be working with a Java application in this section, and then I'll work with a Node Go application in kpack, just to show that, you know, working with different kinds of apps. But right now for this Java app, you can see it's just, this is a Spring Boot app, so you might recognize very, very standard, basic layout of files here. And then I also, yeah.
Thanks.
1 second. Is that good? Do one more. Okay.
That's good. Thank you.
All right. Oh, thank you. Okay, so, all right. So let's talk about, this is that same Docker file. So if you were to run this, basically I want to explain what Buildpacks are, but I want to do it in relation to Dockerfile, right? Because I think it's easier to understand by comparing it to something, using something that you know as an anchor. So Buildpacks have a few different components. One is a platform. A platform basically means that's the tool that you're using as a user, right? I've already mentioned kpack runs on Kubernetes. So kpack is a platform that leverages Cloud Native Buildpacks. But you can also use a CLI called pack. So the tool that you use to build a Docker file is the Docker CLI, right? So actually, let me show you one more line here. So these two commands would be equivalent, right? Pack build and Docker build. So the platform is that utility that you're using. So if we're talking about a CLI, if you need like a terminal kind of experience, an imperative command, you could put this into your GitHub Actions or your CI pipeline. But pack build and Docker build are comparable, right? So pack is a platform, and basically pack is a CLI that implements a platform API that was defined by the Buildpacks project. That's what makes it a platform, and that's why you can have many platforms, because it's whatever tool somebody writes that implements the platform API of the Buildpacks project. Secondly, you would need base images, right? So your base images are equivalent to your from statements. So you were going to need in the Cloud Native Buildpacks model, it's similar to a two-stage Docker file. So you have a build image, that's your base image, that's your build image. And then you have a slimmer base image that is your run image that just has less stuff on it, the stuff that's only necessary for building. You don't want that in your runtime image. But the nice thing is that in the case of Buildpacks, you're guaranteed that these are exactly the same stack, right? Here, I mean, maybe somebody, of course you want, this is good, right? Adopt OpenJDK 11 for both of them, but there's nothing really enforcing that. I could have used two different things, who's to say? So at least with base images, you have that absolute guarantee that, to the highest degree of like the version, the base images are the same for your build time and your runtime. Then you have something called the lifecycle. Lifecycle is a piece of software that was written by the Cloud Native Buildpacks team. And it's basically what they did is say, well, if 10 people were to write a tool for using this, 10 people were to implement the platform API, and then the Buildpacks actually have like all of the language specific stuff. So everything else in the Docker file that talks about like, how do you process a Java application? Like I need Maven, I need to do something with a POM file, I need to do something with a source code. All of that is in the Buildpacks, right? So there's Buildpacks for Node, there's Buildpacks for Go, Java, etc. So that stuff is you know, is not generic. And the tool, right, a user experience of a CLI versus an operator, a Kubernetes operator is not generic. But if 10 people were to write platforms and 10 people were to write build packs, there would be some code that everybody is writing. And that's the code that is sort of like the, how do you orchestrate this build? How, what's the mechanics? What are the sequence of steps to actually have a platform execute a bunch of build packs? So what the project creators did is said, why don't we write a reference implementation of that common piece of logic, and we'll call that the life cycle, and we'll make that available to people so that not everybody has to write it and everybody's using the same thing. So that's what the life cycle is. So the life cycle is comparable to what the Docker daemon is doing, because when you do a Docker build with a Dockerfile, what you're saying is, hey, Docker, the Docker CLI is saying, hey, Docker daemon, here's a Dockerfile. Let me send this to you. And also let me upload all this code. The Docker daemon takes those two pieces of input, and the Docker daemon is the one that goes through the Dockerfile and executes every line and produces a layer out of every command. So the life cycle is helping with those sort of generic mechanics. So that's one way to think about it, right? And so particularly with pack, so we have pack build, then we're giving our image a name. I'm not showing the tag here, but that's how you would do it with the Docker build, -- tag. And then we just have to give it the name of a builder, because we don't want to have to specify separately every single build pack. Like I need the Java Maven build pack, and I need the Java JDK build pack, and I need the life cycle, and I need this base image and this run image. You don't want to have to specify all of those pieces separately. That would not make this easy to use, right? We want something that's easy to use. And so the way that this project is designed is to say all of the pieces that are needed are going to be provided as a single image called the builder. The builder is basically that build image, the image that you're going to use for the build, plus the life cycle's installed there. All of the build packs are installed into it. It has a reference to the run image. So it has everything that you need. So all you have to do is point to this single image. And this image, it's sitting on Docker Hub right now. So if you and I, wherever you are, if you have a Git repo and you run this command and I run this command, and we're both pointing to the same builder on Docker Hub, we're both going to generate the same image, which is pretty magical, right? Because it's not just about making sure that everybody in your organization is doing it the same way. Build packs enable you to make sure that everybody in the world is doing it the same way. So, okay, so there we go. So let's go ahead and
I have a question.
Yeah.
Does including all of the possible things that might be needed, not everything that is actually needed, does that cause bloat?
So that default build pack that I'm using here, the stuff is gonna, I forgot to change the buffer. Oh, it doesn't matter. So the stuff that's in, yes, so that build pack has more than I need. And so it does cause bloat in the sense that like I have to download that once. After I downloaded it the first time, then it's on my local Docker daemon. I don't have to download it again. So yeah, it's a little bit more to pass around. So it is possible, and I'll show you this with kpack. With kpack, you don't just use that one. You generate your own. You can use pieces of that one. You could use all of it if you want, but you have the opportunity to say, I know only builds Java and Node or Ruby or whatever. So I'm going to create a builder that only includes those pieces. And so then I can make, or you could make only a builder for Java and only a builder for Node and have many builders. So yeah, it could, and if it's a consideration, you can create your own builder. You can even with pack, you can create your own builder.
Excellent. Thank you.
Yeah, so you're welcome. Yeah, this is the one I'm actually using Paketo. The Paketo build packs. There's different providers of build packs, but yeah. So okay, let me see how far. I forgot to change the buffer on this, so I probably can't get far enough to show. Okay, but anyway, the point here is that the build happened. I have another opportunity to show you part of the log file, so I'll do that in a second. And so now if I check my Docker images, so what I have here is, here's the builder. So it's downloaded. That's what we're using. That's where the build is going to actually take place. And then after it builds my application, it's going to export all the things that I actually want to production it's going to create a new image using this runtime image and adding to that all the things that are really just what I want to send to production. And so the end result of that is this Java demo image. And these are just my slides, which are running. And this is what Tanzu Community Edition, that's what it used to, that's the image for that. So, so as far as what we're looking at now, it's just those three. So the next thing, okay, so here I'm going to try to show you maybe what I missed a little bit. This is an experimental feature. Anthony Amengo, who's one of the developers on the team, wrote this. It's super cool. So here I'm repeating the pack build command. I don't have to specify the builder actually, because I've already set it as my default. I was just specifying it to show you, but the command can be as simple as pack build and the name of the image. So I'm going to basically kind of issue a rebuild of this image, and I'm going to use this experimental feature called interactive. And what this does is it starts this UI in the terminal that is just a different way of depicting all of that stuff that was scrolling through the screen. So for example, you can see up here on the upper left, it tells me a little bit about the runtime image, and you can see here the builder, which includes, as I said, the lifecycle. You can see what version of the lifecycle is in there, what run image it's pointing at, and then over here on the right-hand side. Okay, so here's the log. Oh, we missed a little bit of this. So you can see here in the log the different stages of the life cycle. So basically the platform, in this case, a pack CLI, is orchestrating this life cycle. It's orchestrating the build by using these different APIs in the life cycle. So first, it does a combination of like an analysis and a restore. So both of these things have to do with efficiency. So if you've already built this image once, then it will have cached certain things, like for example, the JDK. I don't want to have to download that every time I need to do a build. So it's going to cache that. It's going to cache it, like in this case, because I'm using pack, it'll cache it as a Docker volume. But if you're using kpack, it'll cache it in a persistent volume claim, right? Every platform has the opportunity to provide a storage so that it can create this cache, so that upon rebuilding, it doesn't have to download all the things again. So that's one thing it's doing. And the second thing it's analyzing and leveraging as cache is the image itself, right? So it says, if these layers didn't change, I don't have to rebuild them. So it's analyzing both of those things. And so the other thing it does here is detecting. So the build pack contains, as Whitney, as you were saying, right, it contains a lot of other things that you don't need. And so, but this process of detection is a way to automatically deduce which are the build packs that you do need. So you see it has deduced that it's a Maven Spring Boot application. And also it's doing some other things that it might do for all of them. So for example, the SIFT one has to do with generating a bill of materials, right? A formatted list to say, this is what's in this image. Bellsoft is the JDK, JRE, et cetera, right? So, but it chooses the build packs. And so then the next stage after that is building. And so here it's actually going to execute every single one of those build packs in order from top to bottom, right? So first it does something with certificates, then it gets the JDK, JRE. There's some configuration available to you. So like if by default it uses Java 11, but if you don't want to use Java 11, if you want to use 16 and 17, then you can set this environment variable to whatever you want, and it will use that within the constraints of what's in the build pack, right? It also, let's see what it does the Maven build pack. So Maven build pack, you can see that the default command for the Maven build pack is package. Here's package. Here's the default command. Maven test package skip. So skip tests and do a Maven package. If you wanted to, you could take this environment variable and say Maven test skip equals false and package, and then it would run your tests inside. That would be cool. In the same environment that's used for build and runtime. So this is, because this is cached, there's some logging that's not showing up here just because it's reusing layers, but there's some other optimizations that are added, very language specific. Here's one for Spring Boot. So the Spring Boot build pack runs. And so here it says, well, I'm not going to copy a jar file into your runtime image, because then, first of all, the whole jar file would be a single layer, which is not great. Because if you change a tiny thing in your jar file, then you have to recreate that whole layer or retransfer that whole layer. So why don't we split up that layer into pieces? And while we're at it, instead of just throwing them onto the layer in whatever order, let's put them in order of the layers that are most likely to change. So your dependencies would be like your Spring Boot version, right? Your basic dependencies, probably also the biggest layer, and probably not changing unless you change your Spring Boot version. So that goes first. And then you have the loader files if you're using any snapshots. And finally, then your application. Your application is just a few class files. So it's probably kilobytes, not megabytes. And that's what's changing most often. So by separating that and putting it separately as its own layer, then it's enabling the rebuilds, if there's just a code change, to just change that single layer and transfer that layer over the wire, whether you're uploading to a registry or downloading from a registry. So that kind of efficiency is in there. So anyway, so by the time it's finished creating your image, it takes, or creating all the layers, it exports every single layer to that run image. So this is the export stage. And finally, it's not showing up here with its own sign like this, but then the export, I guess, includes the cache. So it caches stuff here. You can see caching, so that next time it runs, it'll have cache available, right? Here it's just reusing cache, but if it had new things to cache, it would cache them. So once this is done, just focusing on this UI a little bit again, then these things become clickable. Like this was gray, now it's checkboxed and it's clickable. So you can go into any one of these, for example, and hit enter, and then you get to see the contents of that layer in the image. So then even here you can collapse and expand and kind of see what's there. These files, you can see that there's information. So SBOM means structured bill of materials. So here we basically are seeing that the Maven build pack created this layer, and in that layer it included files in two different syntaxes, following two different standards, with information about what it put in that layer. And this is something that could be used to scan or just to query and say like what's really in here. And all of these, the file structure for all of these is also very uniform, which is, I'm going to show you one other view of this, so we can talk about that in a second. But so that is this experimental view, which is cool. And okay, so you have a lot of structure and transparency. So a little bit more on transparency. The pack CLI has this inspect command, and you can use this pack, even if you build an image with kpack, you can still use this inspect command with it. So this inspect command is basically going to give you information. You can see that this is very kind of high level info, which is just like, what build packs did I use? What's my base image? What stack is it, right? What's the OS? This is Ubuntu Bionic. So this is stuff that's provided by the lifecycle, basically this level of information. So that's one level of transparency, but you can always see what build packs exactly went into it, what version exactly it was, and it even points you to the GitHub location. All of these are open source, right? So where you can get more info. Now, there was a command where you would just add a --BOM to the end of this, pack inspect image name --, bill of materials, and that would get you the information added by the build packs, right? This is information from the lifecycle, --, bill of materials gave you information added by individual build packs. There's a change to that because the build packs are now going to follow these SIFT standards in how they format bill of materials. So now it's called SBOM, standard bill of materials. And so the way to get that is also changing, I guess. I'm not sure exactly what it'll look like in the near future, but for now, what I'm going to do is actually a little bit of a hack here is I'm going to run the image, right? I'm doing a Docker run so that I can do a Docker copy, and I'm going to grab this layer inside the image called layers SBOM launch. Launch is like what goes to runtime, and then I'll stop the container. So that's just like a tiny bit of a hack to get that out. And so then you can see that. So I've just copied this layers directory from the container to my local machine, right? So now we can see what was in there. So you can see that several build packs created files that have information about what exactly they are putting into the image. So one example would be, let's look at, for example, the Bellsoft Liberica one. So again, this is, so remember, if you have a Dockerfile and you want to know what version of your Java went into that Dockerfile, like, good luck. But here you have an incredible amount of detail. So you know exactly what it was, what version, the provider, everything, right? So that's all the structured bill of materials. And I'll show you one other example, which has information about, this is even more information than like if you look at your POM file for a Java application, right? Since we're dealing with a Java application, your POM file would tell you what version of Spring Boot, but the Spring Boot build pack actually puts in here, provides a bill of materials that has all of the individual libraries. So, like if you wanted to know if you were affected by Log4j, the Log4j library is somewhere in this long list with the exact version. So you could very easily tell if you had been affected by that vulnerability. There's also, I don't know, this is really hard to read, but there's also, the Spring Boot version would be in here somewhere. So you would know exactly what version of Spring Boot went into this. So everything, this bill of materials is there for inspection, right? It's just available, which is pretty big. So yeah, so this command is what you use to run. And also, lastly, you can also inspect the builder itself. And so let's take a look at that. It'll just give you an idea of like the number of build packs that are in there. So the detect stage is really doing a great job of saying, I only need these. And you can see what other kinds of applications this could handle. So Java, it can also do Java native, Python applications, Go applications, etc. Right? All of these things are in here. In fact, and if we scroll a little higher, we'll see it also does a detection order. So if you have more Ruby apps, you should put that first. So it detects your Ruby apps first. That's what that has. And again, the links to documentation. And then here's a little more information. So we know that the life cycle is packaged into the builder image. So here it tells us exactly what version of the life cycle, what version of the APIs it supports, et cetera, right? All this information is in there because there is an idea of these for these images to be transparent, for you to be able to know what's inside of. Okay, so then I'm going to show you inside the image to give you a little bit of an idea. We saw this a little bit when we were building through that experimental UI. Dive is just a separate tool. You can use it for any image. You can use it for your Docker file built images as well. I'm just going to tab here to the right and do a Control U. Okay, so now I'm only looking. I'm back on the left here. So the left-hand side is a list of the layers in the image, and the right-hand side shows the content of whatever layer I'm highlighting. So now I just wanted to filter it so it only showed me what was new. But you can see here in general that there's a very consistent, it's a very well structured, every layer has a very good structure to it. And so for example, here's a layer, and here's layer created by Paketo Buildpacks, and it has certain contents in there. And then here's another layer also by that Paketo. I can't see the right of it, but Java security stuff. Every layer. Maybe if I make this a bit smaller. Sorry, just for a second. Will that work? Okay. Well, anyway, so here's a layer. This is what I was talking about with Spring Boot separating stuff. So here's a 19 megabyte layer that has your Spring Boot dependencies. And that's the first of the 4 layers that Spring Boot's separated out. Here's the second one with the loader files. The third one, so my app doesn't have any snapshots. And then the fourth one, which actually has my code, which is 9.6 kilobytes. And this is a very small app, right? Often you'll be looking at like 100 megabytes of Spring dependencies. So this is really impactful, because if you are, for example, in a situation where you have to send the image out to like 100 or 1,000 or whatever edge nodes, it's much more efficient to transfer 10 kilobytes than it is to transfer 100 megabytes, right? But in general, the fact that all of these layers are so well organized also gives the ability for Cloud Native Buildpacks to be able to swap a layer out, to change a layer more easily. So it doesn't have the same sensitivity to order that Dockerfile does, right? Dockerfile, if you change a layer, then all of the layers after it in the order that they're listed in your script, in your Dockerfile script, are discarded, and you have to recreate them all. But this has less sensitivity to that kind of order because it's just a very well-structured file system. So it helps with being able to swap out layers. So a very different system. So, okay, so let's see, what else do we have here? Okay, let's talk about OS patching. So I'm going to show this to you both with pack and with kpack. So here I'm going to simulate, let's say some situation like a heartbleed, like a Spectre happened. And so because you're using Paketo Buildpacks, you are relying on Paketo, the team, to respond quickly and to release a new base OS image with a fix. And so that's what they've done. And they're like, okay, we fixed this problem. It's version 1139 base image. So we're going to go ahead and pull that down from this provider. So again, that's alleviating a lot of responsibility from people in your organization to be responsible, to be like, you know, on top of like, oh, is there a runtime? Is there a package? Is there an operating system vulnerability? So you're relying a little bit on Paketo to do that for you. Okay, so we've downloaded the fix. Now we want to update all of our images. We want to roll this fix through all of our images, essentially, right? So the way that we're going to do that, first of all, I know that if we do a pack build, then it's automatically, we've set a default builder, right? And so I know that that default builder is going to use this tag for the run image without a version, right? Because that's what I set it to. So the way that I'm going to mock this is I'm just going to rename, I'm going to retag this one that I want to use with this name, so that I know the next time my pack runs anything, it's going to use it because it's going to use it by name. So what that means is that now on my Docker images, I have 3 run images, right? I have the old one, which is not tagged anymore. That's here, E4. And then I have the new one with this tag that I downloaded, it is A6. And then I have it listed here as this tag, base CMB, but you can see it's the same ID, right? So whether I refer to it as base CMB or 1139, I'm using the same patched good operating system. So now what I do is, instead of a pack build, I want to do a pack rebase, which is a slightly different operation. So all I have to do is say rebase it, and it's going to find this image. And what it's going to do is it's not going to recreate all of the images, all of the layers that came from the application. It's going to go straight to the operating system and swap out the layers in the operating system. Same, and on kpack as well. On kpack, this is even faster. Basically what it's doing is the OCI image is a manifest file that points to layers. And so it can actually go to the manifest file and update the pointers, or create a copy of that manifest file and keep the pointers to the application layers the same, and just change the pointers to the OS layers. And so it's very quick, and it's minimal impact to the layers that you already knew were good, and you don't need to rebuild them, and you don't need to waste time rebuilding them. So again, this is very different from Dockerfile, right? If Dockerfile, you change the from statement, you have to throw away the whole image and rebuild all the code. So, which is more risky. So, okay, so then you can see that the log file here is significantly different from the log file of a pack build. All it did is swap that out and generated a new image. So that's that rebase functionality, which is really significant from a security standpoint.
And there was a question of how to build native images.
How to build native images? If there's extra steps, is that the? I don't know if there's any. Are there different steps to doing it? I don't know. I don't know if there's anything different, but I don't know if somebody on the chat has a better answer to that than me. I know that it's slower and it consumes more resources to do it by the nature native images, but I don't think that there's anything different from like a pack perspective. Right, there is a Java, right? So the build pack should automatically detect it. I don't think that there's anything different that you need to do, but is that correct? Okay, so it would detect it just like it would detect any other application. It's okay, yeah. I think I did it once a long time ago. I don't remember. I think I was following somebody's instructions, so I don't remember if there's anything different I had to do. Okay, so what if you wanted to customize something, right? So far we've been building images and just accepting all of the build packs that the process says these are the ones for your app. But what if we want to do something a little bit different? So I'm going to show you a custom build pack. I'm just going to leverage, there's some sample build packs that are part of the build packs project. It's a repo in that organization. So I've just cloned that to my machine. And I've chosen one of these. They have several examples. So this is a Hello World custom build pack example. So, and basically that's what it means, right? It means that you're going to create your own module. So as your app is choosing, these 6 or 7 different build packs to, the Maven and the Spring Boot and the JDK one, you're going to say, I'm going to build one too, and I'm going to include it in the process. So basically build packs are pretty straightforward. There's a metadata file in TOML format, and then you have 2 scripts, a build script and a detect script. So this basically matches like the API of the build pack, the build packs API. So you have to write the code so that when the lifecycle calls your detect script, your script should look at the code and say yes or no, I have to act on this or I don't have to act on this. And just return that to the lifecycle, and the lifecycle will know whether or not to include your build pack in the plan. And then if you did get included in the plan, then when it's your turn to run, the lifecycle will call that build, your build script, and your build script, whatever code you wrote into your build script will execute. So if you're adding layers or if you're manipulating things or whatever, your code will run. So that's pretty straightforward to create it. You can package it as an image and put it up on a registry. In order to execute it with pack, you can package it into a builder, so it's just there, or you can also call it out specifically as a separate build pack. So in this example, I'm calling it out here. You can see that I'm even using it straight from disk. I didn't even bother like creating an image out of it and publishing it somewhere. You can do this as well. This would be great for testing, of course, for example. And I'm also saying, but of course, my Hello World build pack is not enough. Right, I still need to run all the other build packs. So I want to run those other build packs first. Or if I swap the order of these 2 flags, then I'll run mine first, and then I'll run the default ones later. So whichever one you want. So we can give that a shot. And you'll see that here in the detect stage, it's already said, oh yeah, I ran the detect, it returned true. Yes, include me. And also I know because of the order of these things to include it at the end. And then during the build stages, it finished with the Spring Boot build pack, and then it got to my build pack, and here it is executing my Hello World build pack, which just dumps some stuff onto the screen. So that's how to add a custom build pack. So really supportable, right? You're not trying to stray from anything that you could otherwise upgrade. And then I'll just quickly show you this also. So of course, we've been talking about pack as the platform or the tool that you're using. We're going to be talking about kpack, how you can do that on Kubernetes. There's also, if you are a Java developer, then it might be good to know that the Spring Boot team actually implemented that same platform API using the Spring Boot Maven and Gradle plugins. So the Maven and Gradle plugins for Spring Boot are themselves platforms for Cloud Native Buildpacks. So for example, Maven has this new goal called build image. So you can just run this, and it will also leverage Cloud Native Buildpacks to build your application. In the case of Spring, they compile with Maven first, and then they then after the code is compiled, then they start the life cycle. So you don't see the Maven one in here, but otherwise it's all the same. And so, yeah. So I think that might be all I'm just going to show you for Buildpacks. So let me go back here and just say, let's just kind of wrap up this part, which is to say that Cloud Native Buildpacks define a process, the project itself, not Paketo, not the Paketo ones, but just the project, defines a process for turning code into images, right? They created the Buildpack API, the platform API, and then they provided this lifecycle reference implementation of what the common bits that people, so that not everybody has to write them. And they're also providing a reference implementation of a platform by providing the pack CLI. That's also from the project. But essentially, it has a lot of optimizations for fast rebuilds, as we saw, for minimal data transfer. You can do the OS rebasing. It supports this modular functionality, which enables reuse and it enables you to customize with your own plugins. It provides this transparency into the content of the images. And of course, it's enabling this whole ecosystem, right, of platforms, different build packs for different use cases. I'm going to skip this slide for a second, but just to show you maybe in visual format, right? This Cloud Native Buildpacks has platforms and build packs. Platform is the tool you use. The build pack is the stuff that knows what to do with all the languages. Of course, all of that is packaged into a builder, which makes it so all you have to do is get the platform, let's say the pack CLI, and then your builder image has everything else, and then the ecosystem. So here's an example of some of the other tools. So again, we're going to be talking about pack, kpack, and Spring. Actually, we highlighted the first three here. And then there's various choices in build packs as well. So Paketo build packs is actually the OSS. VMware Tanzu is the commercial superset, I guess, of Paketo build. So Paketo, Heroku, and Google all have open source build packs. And then the rebase operation looks something like this, right? If you have an image and your base operating system turns out to be bad, so Paketo or whoever you're using would issue a new runtime image, you would issue this rebase operation. So it creates a second image by copying that manifest file, keeps the pointers to the original app layer, so those are not changed, and updates the pointer to the new run image. And part of the reason it can do that is because there is this ABI as application binary interface, sort of like an API at the binary level, that guarantees that these two will be compatible. It's also partially aided by the fact that these images are so well structured. Okay, then we'll talk about kpack. So I think that was it for here. So any other questions before I hit kpack? Okay.
I'm just popping on to say there's no questions right now.
Awesome, thank you. Okay, so I also hope we're doing okay on time. I think that build packs is probably the longest part. Okay, so hopefully by now you're bought into like build packs are better than Docker files. And you can use the pack CLI. You can put it into your, you can use it at your local machine, of course. It's great for all of these use cases for like inspecting the image. It's a go-to for me all the time for building images. But if you're going to establish a pipeline or you want to do something at scale or more autonomously, then kpack is your friend here. So build packs as a service with kpack. So now, of course, kpack is a product we have to install into Kubernetes. And this is why we started with Tanzu Community Edition in the first place, right? And today with that whole announcement that kpack is now part of this repository of packages that's available if you provision a cluster with Tanzu or if you're using this Tanzu package repository. So let's go ahead and install kpack into the cluster. So let's look at and specifically which packages of kpack are available. So it could have multiple versions. This was just released, so it only has one version in it. So it's the latest version of kpack, which is 050. So that's the package that's available for us. And before I do that, let me quickly go here. Can I not open that? So let's see, documentation. installation. Where's that section? Sorry. I think I have a link somewhere. I'll get to it. But there's documentation on all of these. I'll find the link is going to come up at some point. So, so the first thing we have to do is, of course, we need kpack to be publishing stuff to some kind of registry, right? Because it's not. So to the question about like building images without Docker, kpack doesn't have access to your Docker registry or any Docker registry that it can be publishing images to. It's when it creates an image, it's going to publish it to, I don't know, Docker Hub or GCR or something like that, Harbor, whatever you're using. So I'm going to use GCR for my demo. So the first thing I have to do is give kpack access to my image registry. So I do that. I'm with some values file. So I'm showing you the first few lines here, but basically I'm saying I'm using GCR. This is where I want you to put stuff. And these are my username password. So I can now, when I install kpack, I can provide that information as a configuration file. So that's, and this is from the documentation will tell you what configuration options are expected. So, okay, so let's go ahead and install that. So the alternative to this would be, of course, to go to the kpack GitHub repo, download the release.yaml, and do a kubectl apply with that. Also valid, but this experience is part of a whole sort of Tanzu Community Edition experience of trying to get you a curated, complete set of things that represent a more comprehensive platform, right? As opposed to like, I'm going to go figure out where to get my kpack release file. And then when I want to do something else, I'm going to go figure out from there where to get the release file and managing all the release files by myself some other way and when to update them and all that stuff right here. Because they're all part of this package repository, the experience of building a platform is really facilitated. Okay, so I'll just wait for this to install. Maybe we can go back to the slides here for a second. So kpack is going to be running on Kubernetes, and it's going to do most of the things that pack does. Not everything, because pack is a CLI, but most of those things. And as we say, we're giving it access to write to some kind of Docker registry so that when it creates an image, it can publish. And it's going to need us to tell it what the inputs are, right? So the inputs are going to be like maybe a Git URL for our source code, and then the builder. So the difference here is that if you change your source code or if you change the builder even, like you don't have to issue a kpack rebase. It'll notice by itself that the run image has changed, and it'll do a rebase by itself. So it's a little more dynamic, more responsive that way. And then I had one other slide here. We can talk about it. Let's see. Let's check on the. Okay, this is that. Let's do this. Okay, so kpack is installed, and we can see that it's installed. We can list it out and say, okay, so far we've only installed one package, right? Since we created a cluster. So we only have that. Okay. Now we can start using kpack. So what resources did kpack actually add to our system? And so from here on, you would see the same thing if you had just done a kubectl apply of the release file from the kpack GitHub repo, right? So we see that kpack has created several custom resource definitions. So from, let's say from an operator's perspective, you would be most interested in these three. You want to create a builder so that your developers can build applications. And a builder is comprises a stack, the base OS, right? The base image and the run image, and a store, which is a store of build packs. So if you have a stack and a store, you can make a builder. Once you have a builder, as a developer, what you're interested in is creating images, right? For every time that you have new code, you want to build a new image. So you would define an image that's telling kpack where is your code and where do you want to put the image when it's done. And then every time that there's a trigger to kpack, it'll create a build to handle that particular build of your code, right? And publish an image. So those are basically, of course, and then the difference between builder and cluster builder are the scope. Source resolver is to pull the Git repository, to pull the source. So okay, so first let's talk about it from an operator perspective, right? We have to create a builder. So I hope this part worked. I may have to clean this up. Okay, so this is, as I mentioned, I'm going to use Google GCR. Okay, bear with me. I'm so sorry. I have a cleanup script for this that clearly doesn't work as well as I thought it did, or maybe I am sending it the wrong inputs. I think the script works and I'm not using it properly. So let me just delete this from my last test. Okay. So we should have, okay, so there's no kpack demo repo in here, right? So this is where we're going to be publishing images. So I need to do a Docker login to that repo locally. So that's what I'm going to do here, right? Docker login. So that's just local. Okay, and then they're actually a company, kpack. You could do everything with kpack with kubectl apply, create YAMLs and kubectl apply. And that's likely, if you're storing YAML for like that sort of GitOps approach, that's possibly what you're doing. As an alternative, there's also a CLI for kpack called KP, which I've already downloaded. I'm going to be using that. So so that's what I'm going to be using now. And that's why I do the Docker login. I want to give my KP CLI access to the registry. So the first thing I'm going to do is the store. So the store, as we said, that's the store of Buildpacks. So to your point, Whitney, earlier, I only need Java and Go. I don't need Python. That's, for me at this point, that would be bloat. So I'm going to say create a cluster store, call it default, and just include these two Buildpacks. And because I don't want to write my own Buildpacks, I'm just going to copy the Paketo ones because I trust those. I'm happy with those. So I'm just going to pull those in. So what you can see here, what KP is doing actually, it's not just creating that resource that represents the store in Kubernetes, but it's also reaching out to GCR and copying, relocating these images onto my own registry, which will make it faster. I mean, right now, coincidentally, we're pulling from one Paketo, one GCR repo to another GCR, but I could be doing this on Docker Hub, for example. We'd be moving an image from GCR to Docker Hub. And then when I do my builds on Docker Hub, these Buildpacks are available to me locally, which is faster. And also, I'm not versioning these. Not a great practice, but at least when KP copies them over, it adds the SHA. So it's like, be more specific. So those are both good things. So now one of these is Node, one of these is Java. So if I go back to my registry, I should see that they're both there under KP. So one of these is Node, one of these is Java. Okay, so then we've got Buildpacks. All right, so we've got Buildpacks. We need a base image. We need the base image to do the build, and we need a base image to do the run. We're, of course, going to use the same stack for both. So again, Paketo Buildpacks, just reaching out to what we know here. And the build, notice that this is build, not builder, right? This is because we're going to create a builder. This is just the build and the run. And okay, so we're going to save that as base. So again, KP is going to go out, grab those from their origin and copy them over, resolve the SHA, and put them into my registry. So then once we're done with that, we have our Buildpacks and we have our base images. We can put them together and create a builder that can be used to build images. So, okay, so while that's going on, I'll just review here. Let's review so Kubernetes, so kpack, these would have been the highlights, right? So it gives you Buildpacks as a service on Kubernetes, which is what we're about to see. There is this declarative configuration model. It does automatic rebuilds based on changes in input. So that input could be a change in source code, a change in the operating system. The operating system change would be that rebase that we just saw with the CLI, or language modules, right? If you update the Maven Buildpack or the Go Buildpack or the Python Buildpack. And so you get this consistent, repeatable, transparent, secure build on Kubernetes. Means it's happening at scale, right? So let's see. Let's still die. Not the fastest internet. But in the meantime, any other questions that have come up? Oh, Tasha's here. Hi, Tasha. Cool. Okay, so we have a base. So we go back to the registry. Go back to the registry. We'll see. We should see two more, right? Because we have our run image and our build image. And so now we can make a builder. So remember that when we did the pack inspect on the builder, there was like an order, and for whatever reason, Ruby was at the top of the order. Here we're going to say we have more Go applications. We're going to be building more Go applications on kpack and then Java. So let's put Go first. So that's our little, just a YAML file that's declaring that order. So now when we create that builder, we say, first of all, we can specify where we want that published. So I'm just going to say kpack-demo/builder is what I want it to be. I'm going to use that stack that I just created and use that store that I just created, right? Base and default, these names match here. Default store and base stack. And I'm telling it where my file is that defines the order that I want Go first and Java second. So I can create that. So this creates, obviously, as it did with the store and the stack, it creates the builder object in Kubernetes as well as the image. We put that one level higher here. So we have our builder. So now we have a builder. So now you could even use this with pack, right? So you don't have to use that Paketo one with everything in it. Now in your organization, you could just tell people whether you're using pack or whether you're going to send your image through kpack. Either way, we're going to be, everybody uses this builder, right? So you set this as your default builder for pack. So, all right. So now we put on our developer hat, now that there's a builder. And as a developer, we also want to provide credentials to talk to the registry. And the reason that we're doing this, it seems like we're doing this several times, and it's true, but it's because the operator might want to set credentials for publishing that builder that are different. It's a different service account, right, than the credentials that a developer might be using to have their image published, or that you would create in a namespace that a developer has access to for the developer apps. So this is a secret that we're creating, but in my case, I'm using the same service account for everything. So now we can create images. So again, these could be just YAML files. I'm still going to use that kp-CLI. And just to illustrate how kpack operates at scale, we're going to go ahead and create 3 different images at the same time. So we're going to call our images, let's say we have a shop, right? We're building the website for a shop. So we have orders, inventory, and the shop UI, shop inventory, and shop orders. And so we're also giving them the tag. So what is the name of the image that's going to be published to our GCR registry? So we have, again, shop orders. We're going to put it in the apps repo, shop orders, apps shop inventory, and apps shop UI. We're telling it which builder to use. This is the builder we just created, right? It's called builder. And then where do we get the source code? So this is one of the inputs, right? So well, in this case, I'm actually pointing to a specific revision. If I were to use main here, or the name of a branch instead, then every 5 minutes, kpack would pull this Git repo and see if there's any new changes. And if there are new commits, then it would kick off a build. But so while that's possible, more likely you might have like a CI job before kpack that's testing your code. So you might want to, maybe you do, maybe on a development branch, you want to set that to Git revision dev branch because you want every commit code to be built. That's a legitimate use case. But maybe for production, you only want to build the things that have passed testing. So in that case, maybe your test job would do a kpack image update here, a patch, and change the Git revision every time you actually want to kick off a build. So there's a couple of different approaches. So in this case, I'm choosing that latter approach where I specify the commit. And also, I'm cheating here. I didn't actually write an app. I'm just using a little Go sample app for all 3 of them and simulating that it's different source by having them point to different commits in the repo. So let's pretend they're different apps. So, okay, so let's just execute this script. So these 3 kp commands get executed. So, okay, we've created 3 images. Now, what's happening? So let's look at the list. So you could do, again, this is just a CRD, right? We looked at the list of CRDs. Images was one of them. So you could do kubectl get images. But if you do kp image list, the output is a little bit, there's, I think, 5 columns instead of 3. It gives you a little more, like the latest reason is not there in the kubectl get images. So we've got 3 images where we don't know if they're ready yet. And every image is going through a build. So every image has created a build. Its first build number 1 for all of them. And we see the status is building. They're all working to get built. And also, these are all Go, right? So we saw a lot of Java in the Buildpacks demo. So now we're just setting up some Go applications just to kind of highlight the polyglot capabilities. So while that's happening, we can also check pods. So every build is going to happen inside of a pod. So you can see that they're all happening. They're all at stage 4 out of 6. So these are the lifecycle stages. There's an init container for every lifecycle stage. That's how kpack can do this without a dependency on Docker, because it uses init containers within the pod for every stage of the lifecycle. So it's going through all of them right here. When it gets to 6 out of 6, of course, it'll be ready. And we can even look at the logs. And so here's the one command where you can't really do kubectl logs in the name of the pod because they are init containers. You would have to have a much longer and kind of complex kubectl logs command because you'd have to put these 6 stages in order for them to make sense. So instead of that, you can just use kp build logs in the name of the image, and it'll give you the logs. So here you can see that it's the same log, right? It's the same process. It's just happening on kpack. So it's doing, preparing the code, it's doing the clone, and then it's doing the analyze, detecting, all that stuff. So here we see the 3 Go build, the 4 Go build, the 3 Go build packs plus the certificates build pack. Then it's a first time, so there's nothing to restore. Then it builds, and now it's exporting. And when it's done exporting, then we will see our images show up in GCR. So it should be done in just a second. Okay, so it's complete. So let's check GCR here. So this one, we actually put it in, actually it's over here, in apps. So we have our shop inventory, shop orders, and shop UI. So if I go into shop orders, for example, here you can see actually the tag is associated with the build, right? So it's build 1 and then some timestamp so that you can see which one's newer. So back over here, you can also do a kpack image list again. And now it tells you that they're ready and what the latest image is that was built, right? So as soon as you rebuild, this URL will be updated. Now, what happens, how do you trigger a rebuild? So one way to do it is if there's new source code, right? So a developer made a git commit, that git commit was tested. And so now we want to tell kpack to rebuild that image. So in this case, we're going to do a kpack image patch on the shop orders application. And we're going to say, here's the commit of the code that was just tested. And also we're going to add this parameter --wait, which just causes the logs to be displayed until the end. So we can actually watch the progress of the application. But it should be relatively quick. So now it's just exporting, uploading to the registry. Okay, and then we can go check the registry. And so now we have 2 builds. Build 2 is there, which is great. And then let's look at, okay, we can look at the build list here also. So here you have build number 1 for all 3 plus build number 2 that we just saw. And so you can see here that the reason for this was a new commit, right? This is new configuration. And the reason for this was a new commit. So a little bit different. It tells you a little bit about why it built something. And then let me show you a rebase with kpack. So in this case, the rebase means that the stack is the base operating system, right? Has changed. So again, we're going to use that version 1139, the same one that we used with pack, to say that we want to update our base with a build and a run image that are this other version. So we'll go ahead and do that. It's going to grab this new base and run image, and it's going to copy them over into our GCR, into our image registry, just as it did the first time. And it'll update the Kubernetes cluster stack resource as well. And then that will cause kpack to issue a rebase operation for any image that uses this stack, right? So it'll just take a second, and then we'll see it. Any other questions while we're...
Nope, nothing new.
Okay, all right. Okay, this should be done briefly. It always seems slower when you're watching it.
Tell us about your running this weekend.
Oh, I'm starting small. But I just decided, I mean, I've decided this before, but I've decided again, like not to pressure myself, just to be like, it doesn't matter. As long as like the important thing is to just get out and do it. And like the habit is the most important part. That was my decision. So I just tried to enjoy it.
100%.
I do listen to music when I run, so that's always fun.
Yeah. Any new artists that you're excited about?
No, I've been listening to a lot of Hamilton because I love musicals. But I actually rediscovered, I was able to find an album that I had been looking for years, and that I used to listen to when I was like 18. And this week I actually refound it. Yeah, so I was listening to that recently.
Amazing. We'll let you get back to it.
Okay, we'll get through this. Okay, so we have our new stack, and so and that's been uploaded to the registry, and so we can check what's happening. So here we have, let's see, we have, okay, so this is what so we started with build 1 of everything, right? And then we took orders and made a build 2 by giving it new code. And now we changed the base image. So we expect everything to be up 1. So for shop, we have now a build 2. And you can see that the reason for that is a stack change. Same thing for inventory. We have a build number 2, also stack change. And for orders, we also have a stack change. So it's telling us why. And in fact, I can confirm that this is a rebase and not a rebuild. If I look at the logs, for example, for this one, and you can recognize, right, it's the same short log that indicates a rebase, just a simple rebase that we saw with kpack. So the last thing I'll show you is if you would rather follow sort of that more YAML-driven approach, then you can also use KP to generate that YAML. So you can either use the KP command itself as you're doing something like this, for example, as you're saving. Sorry, I'm going back to the other images, but as you're saving this, you can have it just output YAML, and then you can save that YAML for yourself, right? Or you can use the actual resource that you already created, right? We have an image already created. We can output that YAML as well, save that somewhere. And actually, I've already also saved the YAML for the builder and the stack. So let's take a look at that. And there's also dry run flags. So that's also an option. And there's actually so in this case where you see that as you create this, it also copies these images to your registry. There's a special dry run flag that will not just output the YAML, but that it will also relocate the images. So you've got the images relocated, but you also have YAML that you could maybe apply to different places or save. So there's several ways to get the YAML out of here. So now the important thing about looking at this YAML, I'll just say, is that let's look at, for example, the stack. You just have to ignore the status. You'd have to delete the status, right? You can simplify the metadata. So if you just focus on this, it's pretty simple YAML, right? It's just, I need a stack, and I want the run image and the build image to point to these 2 images, which are the ones that are in my registry, right? And this is the ID of the stack, which is Bionic. And same for the store is very similar. The builder is, if I hide the status and I hide the metadata, then I'm saying everything that I had in the command line, right? I'm saying I want to create this cluster builder. I want to use the stack and store that I created earlier. I want this to be the order of the build packs. And also, this is something that kpack is doing behind the scenes, but it's setting the service account and the namespace. And then same for images. Let's look at an image, shop orders image, for example. Again, let's hide the status and also this metadata. And here we have, we're saying, okay, well, we want to build an app. We want it to be, this is the source code for this revision. This is the tag of the image we want to publish, and we want to use this builder, right? And then it has some, this is the size of the persistent volume claim that it's going to use for the cache, for like the JDK, things that don't go in the run image, things like that, right? So, and you can see the service account name here is different than the operational one that was used for, that's, we gave 2 credentials, right? So it does differentiate between them. So that, I think, is all I have for kpack. So the last thing I want to show you, if you all have energy, I know this is long, but there is one last thing I want to show you, which is, maybe I'll go to these slides first. So let me do it this way. So you've heard this phrase, right? Kubernetes is a platform for building platforms. And so what Tanzu Community Edition is a platform that helps you do that, right? It's not enough to say, hey, Kubernetes is not enough. You got to make something of it. A little help is very valuable. So here's Tanzu Community Edition kind of to the rescue with that. So but that's just the concept of like why, right? So let me show you one more step we could take in building out this platform. So again, we know from when we created the cluster, here it is. Besides kpack, let's choose another one. We're gonna use Knative serving, because the next thing we want to do is deploy, right? We could have used Harbor instead of GCR, but let's say that we want to deploy our container, and we don't want to just create a deployment YAML and a service YAML and an ingress YAML. We actually want to use something that's a little bit more, that caters to more needs, I guess. That has more feature rich. So Knative is a great choice, and it's part of this curated set, and the package is already there. So again, we just kind of like resort to the fact that this package repository is in here, and we can say what versions exactly of Knative are included in this package repository, and we can see that we have 3 versions to choose from. So we're going to go with the latest version. And so here I'm going to actually open up the documentation for that. This is what I wanted to show you before, actually. So here is the docs. It tells you what platforms it's supported on. It gives you, here's the configuration help. So when I did what didn't show you before was packages. When we did the kpack one, same thing, right? You can go to the kpack 5.0. It'll tell you where it's supported. So these are the configuration values that we had filled in before, and it also tells you about the KP CLI. All of that information is in here. So this is a great source of documentation. So now for Knative, we can say, okay, well, there's also some configuration that we might want to do. We're going to set these values, and also let's see. Oh, it has a prerequisite. It requires Contour. Okay, so here it says download Contour 119.1. Okay, so we're going to both install Contour and Knative. You could also go to Contour and see configuration for that. Ultimately, you would end up with this. So I have a config file with the configuration that I need for my local Docker repo, for my local Docker cluster. So I'm setting it up this way with cluster IP personally. And for Contour and Knative, that's my configuration. So now I want to install Contour first, my prerequisite first. So I say version 119.1, like I read in the docs.
Will you zoom in, please?
Oh, yeah.
Thank you.
Thanks for the reminder. Okay, so make it smaller. Okay, All right, so now it's installing Contour, which is the ingress. And it's going to configure kpack to use the Contour ingress automatically. So again, something else that if you were installing these on your own, you would have to make sure that you're doing that right, read the docs and figure it out, which is not always super straightforward. So it's kind of nice that Tanzu Community Edition makes things like that easier as well. So, okay, so we've got Contour. So now we can install Knative. And we're using our same config file because that's got the values for both of them. And so we'll wait for that to finish.
So what's the album that you found?
Oh, it's actually, it's not in English. It's this thing. I spent a year in Israel when I was 17 and 18, and it's an album that I had bought there.
Cool.
And I had like no recollection of the title, but my brother was asking me about some other album that I had bought that year. And then he just kind of like put a thought in my head about how I could look it up. So I literally looked for, I don't know, I found some website that had like lyrics, and it was a really sad album actually, but really beautiful music. And I could never have remembered on my own.
That's wonderful. That's such a great story.
Okay, so now that we've installed, thanks for all the questions, Whitney. So now that we've installed the Contour and Knative, now we can see, if we ask Tanzu Community Edition, hey, what's installed on our platform? Now we can see we have kpack, Knative serving, and Contour. So that's cool. So now that's what I guess the operator or the platform administrator would do, the platform operator. So now from a developer perspective, now we've got this cluster where we're not just limited to doing apply, deployment, service, ingress, and kind of like piecing all that together ourselves, or being restricted to like the limited functionality that offers, but rather we can take advantage of something like Knative, which offers a lot more functionality for our applications and facilitate certain things. So now Knative itself also has a CLI called KN, right? KP was for kpack, KN is for Knative. Again, you don't have to use the KN CLI. You could create a service, a YAML representing a Knative service. So this is not the regular core Kubernetes service, but rather it's the Knative custom resource definition. But in this case, I am going to use the CLI and create the service and just give it a name. And then all I'm doing is saying, this is the image. This is the image that kpack just created, right? And I'm going to I'm creating a namespace to separate this from, I've been working in the default namespace so far. So I'm going to create a separate namespace for the app. And so I'm just telling Knative, hey, do that. So why would it do that? Interesting. Okay, that's the first time that I see that error. All right, who knows? Okay, so we're sending the request to Knative, and we're just going to wait for Knative to finish deploying it. And in the meantime, I can. All right, that's quick. Okay, so it's ready. So so let's see what Knative created. So if you're not familiar with Knative, here's the result of that simple operation. So you can see that you have, as you know, you still have a deployment, you still have a pod. Here's your replica set, but it manages things a bit differently. It manages versions of things through revisions, it provides a route for you. This is the top level sort of service, Knative service resource. And so it adds functionality for you, including being able to scale to 0. Actually, Whitney can tell you a lot more about this than I can. But just to give you a general overview that the experience for a developer of using Kubernetes can be very much enhanced if you have something like Knative versus plain Kubernetes, right? And But part of the problem in leveraging these functionality is that every time that you provision a Kubernetes cluster, it's on you to kind of like enhance the cluster with these things. So that's where Tanzu Community Edition is being really useful and really valuable. So so let's just wrap this up with testing our app, right? We've gone so far, and let me actually, just the way that I'm doing it, I still need to port forward here. So I'm going to open a separate window and just do a port forward to the Envoy service from Contour. This is in Namespace project Contour, and pointing port 8080 over to that. So while that port forward is running, then I can, oh, this is actually the wrong link. Hold on, I need this link. I just wrote it's the wrong namespace. It's the app's namespace. So let me copy it from here. And let's put it in the browser. And we're actually going through port 8080 because we are port forwarding. And there it is. That's my app. That's the sophistication of my orders app. So, yeah, okay, yeah, right. So, okay, so last slide, I think. Okay, so Tanzu Community Edition, just a reminder, just so you know, in case you're interested in using it, it's open source. It's community edition, so it's free. It's not restricted. You don't have to sign up and put your email anywhere. There's no commitment. It's a complete platform. It's the same open source as used in the Tanzu commercial. As you can see, it's easy to use either on Docker. It's also easy on public clouds, either if you're doing a single cluster, if you're trying to manage multiple clusters. So Tanzu Community Edition might be useful to you if you're just trying to learn Kubernetes, then kind of like what I just did is a great scenario, right, for you to build your skills. Or if you're trying to learn Kubernetes on a cloud, then you can also use Tanzu Community Edition to kind of like help, deploy on a cloud, deploy multiple clusters, manage clusters. You can evaluate it, right? If you're just looking to evaluate the platform or evaluate what you could expect from a platform, then it's also, full access, as it says, no strings attached. And you can just use it for development, use it for production, use it for as long as you want as open source software. And then if at one point in time you realize that you do need a path to commercial, then at least you're following the same path to commercial. You don't have to switch products. Or your developer, you can use it for development in the same way that you can use it for production. It's the same. You have something uniform that you're using, as opposed to like, an alternative using two different products for production. So that's it. So here's some places you can go learn more about the things that we've been talking about, whether it's Buildpacks or kpack or Paketo or Tanzu Community Edition. There's also a blog comparing Dockerfile and Buildpacks, making that case. And okay, so now that's everything I had for today.
Is there a place where you can access your slides later?
Yes, I can publish them. And I don't know how would I let people know. I could tweet them.
That's good. Yeah, that's good.
Yeah.
I could also add them in the details for the YouTube for this.
Okay, I'll send you the deck. Can you do me a favor? Can we stop sharing my screen so I can look at it?
I mean, if you stop sharing, it will go away.
Oh, okay. Oh, I have control. Okay, so
you have all the power, but more so, StreamYard just is, I guess, smart enough that if no one is actually sharing anything, I'll just revert back to.
Oh, nice. Oh, Bob, we miss you,
Yeah.
Bob. We miss you so much. Oh, Java Grunt was a huge part of making this a success. So thank you. Awesome. Thank you. Thank you all for staying this long. I know it's been a long one.
It's been really wonderful.
It was good. Good.
Yeah.
Cora, why are you so good? Teach me your ways.
I learned so much doing this. I mean, the thing is, like, I had done kpack and Buildpacks before, but I hadn't really worked with Tanzu Community Edition in a way that I think for me this was like a transition to where I'm gonna use this locally as my go-to from now on. I really I learned a lot from putting this together. I learned a lot about Knative from Whitney. And
I appreciate you, Cora. I appreciate how hard you've worked for this and knowing not only each of these technologies, but how they intersect with each other, and giving context for everything has been great. It's just aces. This has been a wonderful presentation, and thank you for your time.
Thank you. And also, like, congratulations to the whole the kpack team for getting the package as part of Tanzu Community Edition, to the whole Tanzu Community Edition team, who I know have been presenting on Tanzu Tuesdays recently. All of those presentations have been phenomenal, and just like, what a phenomenal project. I'm going to thank Jennifer Kotzen also. She helped me get to this point of doing this presentation also. She's phenomenal. And all the other people who helped me troubleshoot over the weekend, part of the Tanzu Community Edition team and the kpack team. Thanks to everybody that helped. I feel like if I start naming names, I'm going to leave one out. So if you know that you're on the list, I am thinking of you. So thank you.
If you think you might be deserving of thanks, then I'm definitely
thinking about you. Yeah. Your name is in my head.
So Alexander Smirnov has questions if whether the Tanzu CLI can replace Helm. They're really different things. Like, oh my goodness. My bird.
It's another host.
So, like, basically, like, oh my goodness, maybe someone else needs to talk if he won't shush up, but so there's like Carvel tools, which has things like YTT, etc. Shush, birdie. All right, someone else has to talk.
I think I can guess at what you're going to say, which is, in order for Tanzu, the Tanzu CLI is helping you install these packages, right? It's giving you this package repository and giving you this Tanzu package command. And so in that way, it's similar to Helm in that it can help you take something and install it to your cluster. Under the covers, I mean, Tanzu CLI does a lot more than that, because we also, remember, use the Tanzu CLI to provision the cluster, right? And I would use it to delete the whole cluster and things like that. Under the covers, the magic underneath the Tanzu, where it does kind of like do something of what Helm does, it's the highest level it's utilizing other tools underneath in order to do that. So all of those packages that are part of that package repository and that package repository itself, those are put together using the Carvel tool set, and Tanzu CLI is leveraging the packages created with Carvel. So within the Carvel family, which was Tiffany was referring to, that is also a set of tools, and there's one in particular that helps you sort of wrangle YAML, do like overlays or do templating. And so in the way that it manages templating, it does have an overlap with Helm. So I think altogether, yes, the answer is probably yes altogether, but they're not really parallel. It's not an apples to oranges. It's not an apples to apples comparison, if that helps. Mm-hmm.
That was excellent. I linked to the Carvel page too in the chat. Do you have any other questions? I think we're good. Chat's pretty quiet. Do you have any fun plans for your evening? That can be for everyone, for Cora in the chat.
Or the bird. What's the bird doing today?
I'm busy.
Bird is being a butt face and decided, okay, so I changed his cage to his original cage that's way bigger. You would think that'd be a good thing. But this little butthead decided that made him angry or something. So what he's doing is chewing on my fingers, and not kindly either. Like, before I would put my hand over to the side and he would just like snuggle in, head rubs. Now it's like nom 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 on all the fingers, and like
the bird just feels so much power now that its domain has gotten so much larger.
Yeah, I need to figure out clicker training to like get this butthead stop biting, because it starts hurting a little bit. But he's so cute. Like, oh no. Yep, there we go. Oh my gosh.
Yeah.
Oh, yep.
It's like
Got
it's like the bird from Back to the Future, where it's like
He's so
to
chompy.
date myself, but like, yeah. What are you doing, Whitney? What are you doing this weekend?
I every day after work I live very close to a park, so I go on a hike. And today my one best friend's Bonnie is joining me.
Very
So
nice.
I'll meet up with her after this stream. Yeah.
Very fun. Sounds like a lovely way to spend an evening.
Yeah, it's good. Actually, I got in the habit at the beginning of the pandemic because I would never leave my house otherwise. And so it like every day I get some fresh air. I found that it's really great, like time to think and decompress right after all the work, all the heavy thinking of cloud technologies.
Kudos to you for keeping that up for so long.
Yeah. At this point, it's like you just talked about building a habit. Like it's a habit big time. Like I won't even think. I'll just walk over to put my shoes on and start.
Oh, nice. That's my goal. I aspire to that.
You're running. That's a lot.
I ran this weekend. Ask me next time if I'm still running.
I wish I liked running. I really, really don't like running. It's like one of my least favorite possible things.
It's an acquired taste.
Yeah.
Yeah.
That's okay. There are lots of things to do. You don't have to like it. I never could get behind it. I like to rock climb and I like to hike, and that gets me by.
I've only done rock climbing a few times. Bouldering is terrifying because falling scares me. It's fun. I haven't done it since the pandemic started, and a friend just was like, "Hey, I just got COVID from the rock climbing gym," and I'm like, "All right, I'll just stay home."
Yeah. It's killing everything.
What's next on Tanzu Tuesdays? What's on next
week? Next Tuesday, we're doing an earlier show than usual to accommodate our guest schedule. Now that I'm on the spot, I can't think of his name. He's a spring guest and he's doing JUnit testing. And actually, Java Grunt, who's been up in the chat, and maybe even Dan Vega are going to co-host since they know more about Spring. Yeah. So I'm very excited to have them on as co-hosts. And I'm going to.
It's Sam Brennan.
Thank you. Sam Brennan is coming on to talk about testing with JUnits in Spring.
That sounds like fun.
It is going to be fun. And it'll be a chance to get to know our new teammates. So, but we're starting early. We're starting at 9 a.m. Central Time. Yeah.
Okay, so the time's different then.
Whatever the website says is correct. I feel like I'm getting on board. Sorry, I should have been more prepared.
Sorry, no, I shouldn't have surprised you with that.
And then 9 a.m. Pacific time.
Okay, excellent. Thank you, Tiffany AI. I would. And then tomorrow, Layla and I on her stream are going to have a first look. Neither of us have explored Tanzu Community Edition too much on our own time yet, so we're going to do it together and see what it's like from a first user perspective, from fresh eyes, getting it installed. We're going to, I think, install it locally on Layla's machine and see if we can get it.
Oh, great. Tanzu Community Edition?
Mm-hmm. Yeah.
Do you know about the Tanzu to go repository that was created by some of the solutions architects at VMware, Corby Page and a few others? I can get you that repo, but they basically went for like something similar to what you and Layla are probably going to try. So maybe you want to see if you can get that repo from him, and then maybe that would be useful to you tomorrow.
Okay.
Yeah.
Okay. We'll check it out.
You did great work.
Cool. I think I'm pretty interested in also just like getting, instead of being a VMware insider, just like getting the experience of what it is like to go in all bright-eyed and bushy-tailed to the Tanzu Community Edition homepage and see what trouble we can find. Yeah.
Yeah. Yeah. What time are you doing that?
Oh goodness, you're asking me times again. Let me,
Sorry.
No, it's great. You totally should ask me. I have it on my calendar as 10 a.m. Central Time. So that might be either when we're starting or we might go on like 10 or 15 minutes after that.
Okay. I don't know if I can.
The hard way. Exactly
I'll
right.
tune in if I can. So first of all, I think everybody should watch Tiffany and Layla streaming on that. And then if you're not wiped out, then by the afternoon, actually, at 3 p.m. Eastern, Josh and I will be. Is that tomorrow? Yeah. Josh and I will be. Is that tomorrow? Yeah. Josh and I will be.
Oh no, sorry.
That's
me.
Yeah, Josh and I will be.
Sorry. Oh no, stop it. I'm so sorry.
Is it good now? No, that's okay.
I just turned my own volume down and my panic to mute too. It's the worst. Sorry.
But 3 o'clock tomorrow, Josh and I are going to be on Code, also here on the Tanzu Developer Center channels, learning cartographer, which would be like the next level up from what you just saw today, right? Knative. So in order to get that image from Knative deployed onto the image that we generated with kpack deployed with Knative, it took me to do Knative, here's the image that I was the glue between the two. So cartographer is a product that would act as that glue and allow you to create pipelines to say first kpack, you do your thing, now Knative. So that's what Josh and I are going to be doing hands-on tomorrow on Code at 3 p.m.
That's 3 p.m. What time zone?
3 p.m. Eastern.
Okay.
So you have time to watch, right, Layla and Whitney in the morning, then you can go have lunch and then join me and Josh in the afternoon.
That's going to be so fun. Also, speaking of like stuff we listened to in our youth, like cartographer to me. So I used to listen to this punk-ish bands called The Blow. And they have a song called What Tom Said About the Girls. And it's like kind of poppy. And then at some point it just stops. And then she says, did you ever think about the spaces in between the stars? And then it picks back up. And something about cartographer, it's like all the tools, but it's really about the spaces in between the tools. Yeah.
That's so funny. I've heard you say that before. I didn't know the reference. Cool.
Yeah, I think it's pretty obscure. I used to be a snooty little punk rocker when I was a kid. But then again, you're listening to an Israeli musical or something. What did you say?
Well, yeah, I'm listening to either Hamilton the musical or this really old, kind of sad Israeli album.
Also, we have a question of what is a container image?
The image, the image is that tarball basically that contains all of the bits. So the difference between a container and an image, let's start there. The image is the actual tarball that you would store. And then when you want to run a container in Kubernetes, you take that image and you deploy it to your Kubernetes, and then Kubernetes runs the start command, and then you have that code is running inside of a pod in Kubernetes. So the container is the running instance, and the image is the tarball with the source that is your source code plus your base operating system plus all your libraries.
What analogy that I like is like if your running application image is like a cooked dish of food, then your image is the recipe. Your container image is the recipe to make that food, and then your image repository is a cookbook. Yeah.
It's like if you're, if you were, I guess, I mean, that analogy is also great for like if you're a Java developer, like an object versus an object instance. So the object would be maybe like that class file, right? With like your object defined in it. And then when you run it, you have an instance. So your image is that the tarball that you built. So when we're doing all of these Docker pack build or kpack is building something and it publishes a file to the registry, it's basically saying the registry is a place where you, like the storage where you can write it for persistence. And it has a certain format that is compliant with something called the Open Container Initiative. So it has to follow a certain format. but it's really just like a tarball of the content, including your source code. And if that doesn't answer the question, definitely let us know in chat.
Yeah. I like when code has really colorful language, like tarball.
Yeah, the best is Unix.
Yeah.
Like grepping or who knows, there's other.
I was learning about readline, and I think I said this last week. Instead of cutting and pasting, it is killing instead of cutting, and yanking instead of pasting. And then the buffer where it's keeping it is the information is called the kill ring. So if you want to, paste something that you've previously cut, you would yank from the kill ring. And
oh, that's why. Oh, that's interesting. Because when you're working in like VI editor, why you copy with YYPP? So like why they use the Y to copy. So is that where it comes from? From yanking something, maybe?
Yanking is pasting though.
Oh, interesting.
And killing is copy. Yeah.
Huh.
Yeah.
Interesting.
I love that stuff. It's in the read line part. Sweet Killer 9 said never heard of those, and it's in read line. So I learned about it. I'm reading when I have a free moment, I sometimes look at this book called The Linux Command Line to try, because I'm finding like it's funny because if you want to say super cutting edge with technologies, you need to go back and learn like what like the basic building blocks of computers are. So it was the chapter I've been digging my hands into most recently is really just like about command line shortcuts. Yeah. Oh, look, read line killing commands. There you go. Lee posted them in for us.
Oh, nice.
Yeah.
That's awesome. Yeah, there's some really creative names out there.
I mean, in the end, it's good that we all use nice plain language and help each other understand what's happening. We don't want to get too colorful so that it's exclusionary to newcomers, but it's also fun sometimes.
Yeah, it is. It's like that balance between being creative and fun, and then finding something that's really clear. And oftentimes, global regular expression print.
Oh, I didn't know that. We shouldn't. I did know. So grep is global regular expression print. Yeah.
That's so funny. But yeah, finding that, because sometimes it's important to be super clear, and it's fun to be creative, but sometimes it's really just more important to be clear.
Yeah. It's finding the right balance.
Mm-hmm.
Which you did a good job of today, I thought.
Oh, good. Thank you. I had fun, and I appreciate everybody who came to see this. I really appreciate it.
This has been wonderful. I think it might be time to wrap up. What do y'all think?
Sounds good to me.
I think it's that time. Thank you.
All right. It's been
Thank you.
Yes. And see us at our different time next week, and then back to this afternoon time. Right. Bye.
Bye, everyone.
Bye.